What I would like to do is, I have been misguided. I prepared about 20 slides and then saw that I didn't really realize that it was 10 minutes. But I will focus on the most important things. What I will do is, I will try to show you something what our experiences are using 3D surface characterization of a surface and what it can mean in interpreting slip resistance. So, sorry. So what I will try to show you is a bit the experiences that we have using 3D surface characterization, and especially things like the do and don'ts, why we say 3D is better than 2D, what it implies for the use of the method. Well, first of all is that we have been looking into especially one part of the flooring system, of the slip system, especially the flooring characteristics. And to get to an objective interpretation, we have been looking at using optical methods. Why we have been using optical methods, I will skip this part, go over to here, is that when we're looking at the surface characterization, we do the 2D representation, we see that we're missing out on important aspects of the surface, like shape factors and the statistical representation of the surface. So even if we do a lot of profiles on the surface and try to calculate the mean value of it, it's still different than what we can do with the 3D characterization. There is even a 3D standard, an aerial standard, which tells you something about surface distribution, a direction of your surface, which can help to improve the understanding of the surface. The method that we use is one which focuses white light on the surface, then measures shapes, changes in the spectrum. Benefit of that method is that it is possible to, for instance, to use 20 centimeters by 20 centimeters. So you need, for the larger structures, for instance, on tiles or hardened flooring materials, you need to have a bit more of a measuring area. One of the things that is important by talking about surface characterization is that you always need to know how your data are prepared. When we start to focus on functional characteristics, we saw that primary parameters, like we have here, a primary profile, is in fact the most important to correlate with the actual functionality. As soon as we start to filter this, we have to be very aware of how we do the filtering, because it can influence the data that we have. So if you have an R value, which is always a filtered value, it's always good to know which kind of filtering that you use. If you use a large wavy filtering, a large filter length, you always will be addressing the waviness, and the smaller your filtering length will be, the more you will be addressing the small micro roughness. And in some cases you need to play with the settings to find out exactly what is most important for the surface you're looking at. One of the things that we saw is that it's not possible to describe the functionality regarding slip resistance by using one parameter. What we found is we found at least two parameters we are significant, which is, if you look in such a profile, is this core roughness, which specifies the actual roughness in contact with, for instance, the shoe sole, which defines, in fact, the friction. And then there is the peaks in the surface, which define the grip. These are two important factors. What we found out is that there are more important factors which can help to interpret the surface, which is, for instance, the skewness of the profile. If you have a profile, it's important if you have more peaks or more valleys and how regular it is. It's difficult in a 3D measurement to measure peak distances, because then you need an enormous calculating power. And in this case, this simple parameter can help us to look at this kind of situations. Here is a very regular surface, which means that there are as much peaks as there are valleys, which means that you have a good contact, you have a high slip resistance. As soon as the peaks start to go up, you still have a regular surface if you have the same amount of valleys, but you need a higher peak value to get in this situation where you take away your foot from the friction part and you reduce the slipperiness. And if you have this irregular distribution where this skewness is very high, can be plus or minus, but deviation from zero, then you will find this kind of behavior that you get a better and higher friction. To show you a bit what these differences mean, this is just a profile from a 3D measurement. What you see, these are the calculated PSK values from the 3D surfaces. You can see that the peaks as well as the core roughnesses are almost similar. So it's not a difference which can help you to interpret differences. But if you look at the distribution, this is much more irregular than this one. And what you can find is that here we have almost 2 times the slip resistance with all of the measurements that we can do than in this situation. So the roughness is the same, but the distribution is different. So it means you have a very large impact on your slip situation. Well, this is something that Richard also showed tomorrow, has shown you this morning. What we see is that we use this kind of slip assessments to make a distribution and a differentiation of flooring surfaces, which helps us to understand why measuring methods behave like they do on different surfaces. Just to give you some examples, this is, I think, the same result that UK slip resistance got by looking at, for instance, contact angle on the ramp with oil with the pendulum with slider 69. We see that there are a lot of surfaces which do not meet the safety requirements, but which are in fact R10 values. If you take this one, which is too low, and this one, which is barely, when you look at the repellent value in the moderate stage, when you look at the surfaces, you see this difference of the contacts. So here we have a high value, here we have a lot of grip, here we have a loss of contact area, and this explains why we have this value down here. So it helps you to understand why certain surfaces act like they do. Also, if you do a single measurement with a single parameter, you would expect them to be the same. This, of course, is something that is important when you start talking about reference surfaces. When you look at the amount of commercial tiles and surfaces that we can find, here we have the core roughness and the peak height. We look at, for instance, these are the smooth tiles, these are the micro rough tiles. When you look at where the reference values are located, you see that most of the references for the pendulum, also for the shoe tests and for the GMG are in this area. Here are the reference surfaces for the ramp. Here is another one for the lower ramp area. But you see there's a large gap between actual application areas like this, where we do not have a reference surface for it. So it's always the question, do you do the calibration of your surface to test your method, or do you want to look how the method performs on a certain surface? And here is definitely an amount of surfaces where reference is lacking. Well, this is a bit of something else. We did a lot inventory of different kind of tiles and looked at exactly where we were with slip resistance. As you can see, it has no linear correlation. The amount of combinations that you have on different kind of surfaces, this is the peak height, this again is the core roughness, here is the area of high skewness, this is the area of a low skewness, which means that depending on how your situation is, you can get very different results. If you have the smooth area, for instance, and we look at this kind of surfaces, you can see what we always address as a problem for the smooth surfaces. These are the 3 different measuring methods. And you can very clearly see the differences in how they approach the slipperiness of a smooth surface. This is what we see, what we call always the differences in the different kind of interpretations on these kind of surfaces. Well, just quickly something about where we are going. There is a 3D standard which will help us to better understand the functionality of the flooring surface. One of the problems is the methods that we have are very expensive, are in a laboratory, but there are developments going on, as you can see here, and also this, where we are trying to get the method in a mobile form, where we can put it on the floor on site and help us to interpret what we are seeing when we are doing the slip resistance measurement. This is, of course, another method, applicable method. If you want to go on site, we can also try to get the machine there. We also can try to make, what we do here, a duplication of the floor. It's, in this case, it's accurate as we need, not as it can be. So 2 microns accurate is enough to make your slip interpretation. We make this kind of duplications and use this to look at this kind of wear effects, for instance, in the practice. So what we do here is we have this. This is in fact what we're looking at. We can see that we can use the surface characterization interpreting slip resistance. We can use it looking at the reference method, reference materials. One of the things that we discussed, what Gonzalo said, is very important. We're looking at the wear changes in surfaces, and it can help also to develop, like say, wear-resistant surfaces by looking at the aspects you have to address in the design. And with that, I would like to close, and thank you.